How China built the $300 million bridge over a massive canyon. Imagine standing at the edge of a canyon so deep that if you drop a stone, you won't hear it hit the bottom for almost 4 seconds. Now imagine someone looks at that canyon and says, let's build a bridge here. Not a small bridge, not a simple one. A bridge so massive, so insane, that the entire world stopped and stared. And China didn't just build it. They built it in record time with technology that most countries don't even have yet. So today, I'm going to take you inside the full story. The engineering, the madness, the risks, and the moments where this project almost failed completely. And trust me, the last part of this video, that's where it gets truly unbelievable. So stay with me till the end. Let's first understand, where exactly is this bridge and why did anyone even think of building it? This is the Beipanjiang Bridge, located in the Guizhou province of southern China. Now, Guizhou is not your typical flat city landscape. This place is basically one giant maze of mountains, valleys, and deep river gorges. For decades, people living on one side of this region had almost no connection to the other side. Think about it this way: 2 villages, maybe 50 kilometers apart on a map. But to travel between them, you'd have to go down one mountain, cross the river below, come back up the other side, and that journey? That could take 4 to 5 hours, every single day. Kids missing school, farmers losing crops because they can't get to markets in time, sick people not reaching hospitals fast enough. This wasn't just an inconvenience. This was a daily tragedy for thousands of people, and China decided, enough is enough. So the plan was simple in theory. Build a bridge that connects the 2 sides of the Nizhu River Canyon directly, cutting that 4 to 5 hour journey down to just a few minutes. Simple plan, insane execution. Because here's the problem nobody talks about enough. The canyon is not just deep. It's 565 meters deep. To give you a comparison, the Eiffel Tower is 330 meters tall. You could stack almost 2 Eiffel Towers inside this canyon, and they still wouldn't reach the top. The wind down there is unpredictable. The terrain is impossible to access. There are no flat surfaces to work from. There are no easy roads to bring in equipment. And they needed to build not just a bridge, but the tallest suspension bridge in the entire world at that time. The engineers who first surveyed this site, some of them later said they genuinely didn't know if it was even possible. But China said, let's figure it out. Now, before I tell you how they built it, let me just quickly tell you what makes a bridge like this so incredibly complex. Most bridges you've seen, they sit on solid ground. The pillars go into the earth below them. Simple forces, simple foundation. But a canyon bridge? Everything changes. The 2 anchor points are on opposite sides of a 565-meter deep gap. The main cables holding this bridge. Each one carries a load of thousands of tons. The towers themselves are over 260 meters tall. That's taller than most skyscrapers in the world. And every single calculation has to be perfect. Because if the tension is even slightly off on one side, the whole structure starts to twist. And a twisting suspension bridge is a disaster waiting to happen. Remember the Tacoma Narrows Bridge collapse in the USA back in 1940? A suspension bridge started vibrating in the wind, and within hours it literally tore itself apart and collapsed. The engineers on this project had that in mind every single day. So how did they actually start? Step 1. They had to get people and equipment to the site, and this itself was a massive challenge. There were no proper roads leading to the canyon. So China did something that sounds almost cinematic. They built temporary roads just to build the bridge. Roads that were only ever going to be used during construction. Massive excavators, steel beams, concrete mixing plants, all of it had to be transported through mountain roads that barely existed. And then came the first truly insane part. How do you connect 2 sides of a canyon when there's nothing in between? You can't exactly walk across. You can't extend a crane from one side. The gap is too wide, the drop is too deadly. So the engineers used a technique that sounds like something from an action movie. They used rockets, literally. Small rocket-propelled lines were fired across the canyon. These thin lines were then used to pull slightly thicker ropes. Those ropes pulled cables, and those cables eventually became the initial working lines, used to set up a temporary aerial tramway system across the canyon. Workers would then cross the canyon on this tramway, basically a cable car, hundreds of meters above the ground. to begin construction work on the other side. Can you imagine being one of those workers? Now here's where the engineering gets truly next level. The two main towers of this bridge, they're not built on the canyon floor, they're built on the cliff edges on either side. And cliff edges are not solid flat surfaces, they're irregular. They're made of rock that has been exposed to weather for thousands of years. You can't just pour concrete on top of that and hope for the best. So first, the foundation work. Teams of engineers and geologists went in and literally analyzed every square meter of rock on both cliff edges. They drilled deep into the rock in some places going 30 to 40 meters down, and inserted massive steel anchors that locked the tower foundations directly into the mountain itself. This is called rock anchor foundation technology, and China had developed some of the most advanced versions of this in the world. The towers were then constructed on top of these foundations, using a technique called slip forming, where concrete is poured continuously around the clock without stopping. So the tower rises slowly but without any weak joints or breaks in the structure. Both towers, 269 meters and 247 meters tall, built simultaneously from both sides of the canyon. Now here's a midpoint I want you to pay attention to, because this is where most people don't realize just how smart the engineering really was. The main suspension cables on this bridge, there are two of them, one on each side. And each cable is not a single wire. It's made up of thousands of individual steel strands bundled together. Why? Because if one strand breaks, and over decades, some do, the bridge still holds. The load is distributed across thousands of points, not concentrated on one. Each of these main cables is anchored into massive concrete blocks on both sides, buried deep inside the cliff, and the tension on these cables is so high that the force on each anchor point is equivalent to the weight of around 10,000 cars. All of that force, held in place by engineering and mathematics. And then, the deck, the road surface you actually drive on. The deck segments were not built on site. They were prefabricated in factories, hundreds of kilometers away, and then transported piece by piece to the canyon. Each segment was then lifted by cranes mounted on the cables above and carefully positioned, connected, and locked into place. This process alone took months, because you can't rush it. One misaligned segment affects everything that comes after it. But here's the part nobody talks about enough: the weather. Guizhou province is not known for easy weather. During certain seasons, the canyon area gets thick fog, sometimes for days at a time. Visibility drops to almost nothing. In those conditions, work stops completely. You cannot position steel segments you cannot see. You cannot run cranes in zero visibility. And then there's the wind. At 565 meters depth, the canyon creates its own wind patterns, unpredictable gusts that can destabilize equipment, endanger workers, and affect the tension in the cables. Every work session had a weather window. Engineers would wait, sometimes for days, for the right conditions. And the moment conditions were good, everyone went in, worked as fast as safely possible, and then pulled back again. This stop-and-go process added significant time and cost to the project. And yet, despite all of this, China completed this bridge in approximately 4 years. For a project of this scale, that is genuinely fast. Let's talk money for a second. The total cost of the Beipanjiang Bridge was approximately 2.9 billion yuan, which at the time translated to roughly 300 million US dollars. Now, 300 million sounds like a lot, and it is. But here's a perspective that completely changes how you see that number. Before this bridge, the economic isolation of that region meant that businesses couldn't grow, trade couldn't happen efficiently, and the government had to spend massively on alternative routes and infrastructure support. Within just a few years of the bridge opening, the economic activity in the connected regions increased significantly. Tourism picked up, trade routes shortened, property values on both sides went up. In other words, the bridge didn't just cost $300 million. It started generating value almost immediately, and economists estimate that over a 20 to 30-year period, the economic return on this bridge will be many times its construction cost. Infrastructure is not just construction. Infrastructure is investment. China understood this, and they went all in. Now let me tell you the one moment during construction where everything almost went wrong. During the final stages of cable installation, when the main suspension cables were being tensioned to their final specifications, engineers detected a small but concerning asymmetry in the load distribution. One side was carrying slightly more tension than designed, not massively off, but enough that, if left uncorrected, it would cause uneven stress on the tower foundation over time. The team had two choices. Option 1. Continue. Accept the slight variance and monitor it over time. Option 2. Go back, adjust the anchor system, retension the cables, and delay the project by several weeks. They chose option 2. Several weeks of delay, additional cost, but they chose to do it right. And that decision, that insistence on precision even when the easy path was available, is what separates world-class engineering from average engineering. The bridge opened in 2016, and the reaction was exactly what you'd expect. The world's engineering community was stunned. Organizations that track major infrastructure projects, they had seen ambitious bridges before, but nothing quite like this. It held the record for the world's highest bridge for several years, until China itself broke that record with another bridge. Yes, China then went and built an even taller one. But the Beipanjiang remains one of the most celebrated engineering achievements of the modern era. Not just because of its height, but because of what it represents. It represents the willingness to look at the impossible and say, let's figure it out anyway. Here's what I want you to take away from this. We look at a project like this and we see a bridge, a road, a structure. But what it really is thousands of decisions made correctly, under pressure, in impossible conditions, by people who refuse to take shortcuts. The engineers who fired that first rocket line across the canyon, they didn't know for certain it would work. The workers who crossed on that tramway hundreds of meters above the ground, they showed up anyway. The team that delayed the project by weeks to fix a small asymmetry, they could have ignored it. They didn't. And that's actually the lesson here. Not just about bridges, but about anything difficult in life. The gap between average and extraordinary is not talent. It's not even resources. It's the decision to get it right when getting it wrong was the easier option. China built a $300 million bridge over a canyon that most people thought was unbridgeable. And they did it one correct decision at a time. If this video gave you something, a new perspective, a bit of inspiration, or just genuine amazement at what humans can build, then share it with one person who you think would appreciate it. And if you want more stories like this, real engineering, real history, real lessons, you know where to find me. I'll see you in the next one.